Hello, I'm Jim Cornell, and this is Base to Base, the weekly biotech podcast from Air Coastal Media. Yes, welcome again to the Base to Base biotech podcast, and this is number 68, and it's going live on July the 17th. No mention of the weather, but it is warm. Last week our guests were Amy Walker, CEO of 4Base Bio, and Adam Tomasi Russell, Senior Director of Climate at Deep Science Ventures. And it was another popular podcast, What is Going On? More than 400 hits in the first couple of hours that it was live. And no, none of them were me hitting refresh. This week our guest is Kyle Cordova, founder and CEO of AquaPoro, a company with connections to a whole range of other industries, including life sciences and pharma. Stay tuned. If you do have news or suggestions for who should be on the podcast, or indeed any other suggestions or comments, please do get in touch at jim@deeptechdigest.com. which is also the address you can use if you're interested in advertising with us, or sponsoring a podcast episode, or for event coverage, or to complain about the weather. Too hot, too wet, too dry. Actually, we'll cover too dry in a minute or two. But first, it's time to go through some of the headlines of the news articles you may have missed over at deeptechdigest.com over the past week. Epigenetic mapping provides deeper insights into leukemia. An anti-cancer nano-switch technology has been developed, and there has been an $18 million investment in malaria, TB, and NTD projects. Microbial cell factories are one step closer. There have been positive results from a plantar fibromatosis trial, and AI technology can detect the early warning signs of cerebrovascular disease at home. Scientists have uncovered genetic clues from a tumor-prone reptile that could advance cancer research. A non-muscle invasive bladder cancer treatment has received FDA clearance, and bowel cancer samples could boost the understanding of other killer diseases. Metabolic syndrome has been linked to faster brain aging. New phase 1 data show the potential for neurodegenerative disease treatment, and you can read all of these and plenty more at deeptechdigest.com. Alright, let's get to this week's interview. It used to be the case that water shortages were really associated with arid climates, like the Middle East or the interior of Australia. But with climate change, water is becoming a valuable resource and an issue in many places. Lots of national parks have no fire rules in place, and here in the UK there are hosepipe bans in many parts of the south. One way to deal with this is through technology. AquaPoro is a Deeptech company set up in Jordan, but now based in California, and it engineers systems that can harvest water from the atmosphere. Of course, I have lots of questions, so to answer them is Kyle Cordova, founder and CEO of the company. And after talking about baseball for 20 minutes, which I think was actually legitimate because ballparks use water as well, we did move on to AquaPoro. All right, thanks for joining us today, Kyle, to talk about water harvesting. I wonder if you could first give us a bit of background on the company.
Yeah, so AquaPoro is a Jordan-founded but now San Diego-based deep tech company that it makes machines that produce water from the air. The way that we approach this is through a proprietary platform called ALMA for short, or atmospheric low-humidity moisture adsorption. That's a mouthful. What that basically means is that we use these really highly porous sorbent materials to selectively pluck out water from the air, concentrate it, and then find a way to release it from those porous materials to then condense the water vapor into liquid form. Sort of our claim to fame is that We can open up the operating conditions. So we can go to really low relative humidities in dry desert and arid environments, and we can work really well in high humidities.
You said it was from Jordan. Are there other places where it's being used?
We discovered this process and this technology in Jordan. The reason for that is my background. I'm not Arab, I'm not from the Middle East, but I found myself in Jordan. My background's in chemistry. I did my graduate work at UCLA and then Berkeley. When I finished up my grad work, I founded an institute in the College of Chemistry called the Berkeley Global Science Institute. And the idea was that science was exclusive, that few people in few countries and at few institutions were really the ones able to push the ball forward in making important, impactful discoveries that address societal challenges. And so what that meant was for the last 15 years, I was living in countries primarily in the global south and building physical research centers, creating research programs that would address national priorities, and then mentoring emerging scholars on how to pursue impactful research. That journey led me to Jordan. And when you get to Jordan, it's the second poorest country in the world in terms of available water resources. So I knew the first research program that we had to pursue was how to create net new water, not make the water infrastructure more resilient or more efficient, not to clean the water better, but literally create a new source of water. So my background is in a field called reticular chemistry, and the hallmark class of materials in that discipline is called metal organic frameworks, or MOFs. MOFs just won the Nobel Prize last year. My graduate advisor that I was building all these centers with was one of the winners. And my research was cited in the scientific basis for my former advisor winning that. So I've had a lot of experience designing and developing these really cool materials that have a lot of different use case applications. And so my background was in carbon capture before I got to Jordan. We were always trying to get rid of water. Water and CO2 sort of compete for the same sites, same adsorption sites inside of these porous materials. And so when I got to Jordan and I realized the severity of the water crisis, I thought, well, I have the perfect material to flip and actually go after and capture water directly from the air. So we designed that material, built a machine around it, and proved that it can work in this really dry desert context. Published a really big paper, as an academic does, which was like the highlight. It was in Nature Communications, so very prestigious. And then a very big guest visited our research lab, His Majesty King Abdullah, and said, basically, Kyle, how do we get this nerdy device out of your nerdy lab and out into society? I said, give me an order. He asked how many, and I said 1,000. I thought it was a big enough number. And he said, done. And so that night I went home to my wife and I said, I think we're founding a company. And she says, I'm on board. So we founded the company in Jordan, raised our first round from, we're very proud to say this, Jordanian investors with some friends and family in the US. And we started building, AquaPoro and the technology to translate this from the lab to society.
What brought you back to the US then, if you have the company there?
That's a really good question. Founding a deep tech hardware-based company in a country that doesn't have a lot of experience or mature capital markets to make this happen, or reference cases or win cases, it's always a challenge. There's a ceiling. And so I made a heart over mind decision to found it in Jordan. I wanted to do it. This is a discovery made by Jordan for Jordan. And after you break through those first couple of ceilings, you realize that it's going to take a lot more. And so we made the difficult decision. I had to make a mind over heart decision this time to move it back to the US, where we can access the capital that is needed, the infrastructure that is needed to really scale this and make the impact that we set out to make. So I made that decision about 2 years into the journey. So we built for 2 years in Jordan. And then last March, I moved to San Diego.
But will it still be applied in Jordan?
Totally. Yeah. So so our commercial director is still based in Jordan. We have 2 different machines right now. The most mature one is called Droplet. It's a domestic residential device. It's what we did a lot of the design engineering work on in those initial sprint. We're in the DFM, so the design for manufacturing and design for assembly stage right now. And we've set up this really fantastic group of distributors across the region. So Jordan and Middle East at large is really the first market for our domestic residential device.
What industries would this be applicable to?
I don't want to say that I'm naive enough to think that Droplet is on cruise control, but it's most of the technical work is finished on Droplet. And now it's about execution, getting it out, go to market, right? And so we've shifted our focus from Droplet to our larger implementation, which is called Stream. We collected a lot of data and really understood this process working through Droplet. Droplet being 5 gallons of water every single day, or 20 liters of water every single day in really tough conditions like Jordan, 20% relative humidity and 30 degrees C. We always wanted to increase output. To increase output based on the architecture of Droplet, it's really challenging. The physical footprint of the device has to become really, really big, which is a challenge. Real estate is not cheap. And so we turned to an engineering science that the oil and gas industry has been using for decades. It's called fluidized bed or fluidization processes. These are big, really big columns that are used to separate gas mixtures, and they're scalable. And so for Stream, we started approaching the scale problem by turning to these fluidized technologies. So with Stream, we can start to produce industrial level output. The industries that we're targeting, the strongest pull that we have gotten to date is food and beverage manufacturing. After that, any industry that needs ultra pure, high grade, ingredient grade water. So you're talking semiconductor manufacturing, pharmaceutical manufacturing, and of course, data centers. But our strongest pull to date is F&B, food and beverage.
There are countries, obviously, we're talking about arid countries like Jordan where this makes sense, but there are countries like Spain that do have water, but seasonally now seem to have an awful lot of problems with shortages of water. Is this going to be applicable in other countries as well?
This is happening in the US right now. And as you just referenced, this is a playbook that has played out multiple times in other contexts. This last winter was the driest winter that the west of the US has had in a very long time. Snowpack is at its lowest. That's led to states like Colorado declaring a stage 1 drought. With no snowpack, you can't feed the Colorado River, and that's having a material impact on industries. There's a statewide reduction by 20% in water allocations. That's affecting businesses, that's affecting people. So this is something, seasonal sort of variations, climate change, is having a major impact on water availability.
This will be able to help with that as well.
Our phone has not stopped ringing saying we're getting 20% of our water cut. How quickly can we implement your large scale system Stream? We have had customers say we are desperate, which is never a good sign for them and for water in general.
When you take water from the atmosphere like you're doing, does that contribute to water scarcity elsewhere, or does it adversely affect microclimates in the particular region that you're doing this extraction?
It's a great question. And I think anyone who asks that question is thinking deeply about this. We obviously set out to solve a massive global crisis in water, and you don't want to come up with a solution just to create another problem down the line. What I can say is nature's water cycle is incredibly dynamic. So the process of evaporation from the oceans and moving that across the world is a very dynamic process. The scale at which atmospheric water is working right now doesn't make a dent whatsoever on humidity reduction at the macro scale. So that means that there's no impact on climate patterns or weather patterns. There's no impact on biodiversity. You can think about these proliferating 100 years down the line and what will be the impact on that. No credible, deep study has been done on that yet. But for the scale at which we operate, it doesn't make a dent. There's something like 16 sextillion liters of water in the air at any given moment, and that is constantly being replenished by nature's water cycle. So I used to lose sleep about that in the early days, and then started doing some preliminary calculations, and then I realized that it's not going to be an immediate consequence.
Right. Are there any challenges, though, to this process?
Totally. I think sorbent-based, or what we call adsorption-driven atmospheric water harvesting using solid sorbents solves a lot of the traditional challenges of AWG. So I should probably frame that we are not the inventors of air to water. Your air conditioner at the end of the day is an atmospheric water generator. There's a little pipe and condensate comes out. You are literally creating water from air through that process. And in the early days, it was all about making more efficient air conditioners, basically cooling the air down to the dew point where water vapor undergoes a phase transition to the liquid state. They ran into 3 fatal flaws. The first flaw was you're constrained to ideal environmental conditions. So you need high humidity, greater than 60% typically, relative humidity. The second is that outside of those ideal conditions, your energy starts to skyrocket. And when energy starts to skyrocket, then your levelized cost of water that you can produce also starts to skyrocket, and it becomes economically infeasible. And then I think the third and most underappreciated is consistent and reliable and continuous production of water every second of the day. If you can't constantly produce water, then you limit your use cases, right? If you're batching, pausing, and producing, then people have to wait for your process to work. Adsorption-driven atmospheric water harvesting, so the sorbents, this approach addresses all of those fatal flaws. The challenge now really comes down to driving down the cost of energy consumption. What happens in our process is we capture the water and then we heat it up, and that heating up requires a lot of energy, even if it's to 60 to 80 degrees C. And so the primary engineering challenge, it's an energy engineering challenge, not a process challenge. And we have a lot of clever ways that we're approaching that to get our energy consumption as low as possible to drive our levelized cost of water as low as possible.
Is there any issues with contaminants?
Totally. I mean, these systems will be applied in polluted areas and non-polluted, open sky areas. Air is your primary input resource. And if that is contaminated with even dust, let's not talk about the standard air contaminants that could come out in your water. And so we take care of that by a series of air filters that purify or clean the air before it even comes into the sorbent chamber. The sorbent itself is a selective adsorption process. So it's selectively capturing water. So the gaseous molecules that get past those filters are also just passing through the material out the exhaust. Once the water is collected, if it's going to be mineralized, it's put through a carbon or charcoal filter, plus the minerals that need to be added in because we're just generating deionized distilled water. And so that's a third sort of final purification step.
You were mentioning about the early days where you stayed up at night worrying about the technology. Do we also need to, as well as implementing technology like this, concentrate efforts on using less water? Things like plant-based diets, improving data center efficiency, less irrigation. And do you think that when technologies like yours gets implemented, that people kind of breathe a sigh of relief and say, well, okay, now we don't have to worry so much about using those methods of using less water?
It's a really, really good question. The water crisis is so immense, it's very difficult to wrap your head around it. I think you brought up, one point of seasonal fluctuation and variation and seasonal effects. Demand is always there, but the supply isn't always there. The true, honest answer is that there's a suite of solutions that have to be implemented. Demand reduction, conservation, these are not competing policies and strategies. I think because it is such an immense problem, there is space for all sort of approaches to be implemented. I mean, think about agriculture just as an industry alone. I think it accounts for something like 70% of total global freshwater use. And so even a meaningful reduction or a minimal reduction in that will have a much bigger impact than what our technology can provide on the supply side. It's a delicate balance. Desalination is a very important technology for a lot of different regions. It just comes with its own environmental challenges and the fact that it's coastally constrained. So our solution comes in to where water is not available, where water supply is not of high quality. And so there's a lot of cleaning that comes into it, where people or industries need to create redundancy because of supply issues, seasonal supply issues. Yeah, and they want to build out a more robust sort of water infrastructure for themselves. It's an additive, not a competing sort of technology.
And is the technology something that can evolve and improve over time?
1,000%. My background is in chemistry. I love porous materials. I've dedicated my life to studying them. But AquaPoro is an engineering products company. All of our machines are materials agnostic. And that was a very deliberate decision in the early days because we're long on materials innovation. Capacity of those materials are constantly being improved. The adsorption, desorption kinetics are constantly being improved. The thermodynamics are constantly being improved. So inevitably that adsorption, that ALMA process will continuously be improved with subsequent generations of absorbents that are in our pipeline of development. We're also seeing big step changes as we start to scale the technology output. A lot of the early days focused on domestic residential devices, creating systems that can provide personal or household level supply. When you start to scale, there's all of these engineering gains that you get, or on an energy optimization sort of side, and also on a throughput or output perspective. And so we're building bigger and bigger machines. I don't think anyone has come close to what we're doing with Stream, and that's exciting.
Do you see that this is something that could be applied to other industries? I mean, we're primarily a life sciences platform and podcast. Is something that can be utilized in those other industries?
We've gotten a lot of interest from pharmaceutical manufacturers. The water purity and quality requirements for their facilities is of the highest standard. And that's exactly what we deliver is ultra pure deionized distilled water. What is really interesting and what we've found is it's really nice to frame what we're doing as a silver bullet to the water crisis. It's net new water, it's new supply. In the fullness of time, we'll be able to produce at the municipal level. But I think it also distracts from the actual business case of this. And pharmaceutical manufacturers are probably the best industry to give as a case study. Everyone thinks that water costs what they pay at the tap. Industries understand that that's not the case. If they can even source the requisite amount of water, they pay whatever that is. If it's trucked in, if it's from their own private well, if it's from the grid. But that begins a long process of cleaning to get it to ingredient grade standards. They have to do ultrafine filtration, UV sterilization, 2 or 3-way pass RO. They have to mineralize it. And then they also have discharge penalties when they're done with their process. When you stack up that total cost, what we call the total cost of ownership of water, it is 5 to 10x what you're paying at the tap. And they know this. And so if we can come in and not only provide them with ingredient grade water, but we can lower their costs, then it's a no-brainer for them. And I think F&B understands this directly. Semiconductor manufacturing and pharmaceutical manufacturing also understand this directly.
And what about footprints in terms of there's often issues over wind turbines too big? Are they interfering with the
Yeah.
environment? And you get the same kind of thing with the potential for tidal energy. It's clearly a green technology, but is there an issue of where we're going to put these things and is it going to be an issue?
Everyone in hardware seems to want to design to a 40-foot container. It makes logistics, it makes everything easier, right? That's how the world operates with large machinery. It limits your approach. And I was very fortunate after we built our proof of concept Stream device, talking to our flagship customer in F&B. And their first question was not, how much does it cost? How much does it produce? All of the normal things that I would expect. It was, how big is it? Real estate is too expensive, Kyle. The beauty, that was kind of an aha moment for us. The beauty, because we were building it horizontally to, pack in those 40-foot containers. The beauty of fluidized beds is in order to scale output as you build up vertically. So since last summer, we have redesigned in collaboration with this flagship customer, a vertically oriented Stream system. So it minimizes the base footprint, the real estate cost, and it can reach the desired output for this deployment. So I think that's the way. It makes shipping, transportation a little bit more challenging. We'll probably have to assemble on site as opposed to shipping a fully assembled plug and play sort of machine. But it solves a major problem for these industrial users that don't have land, don't have space.
Are they being sold already or?
Yeah, so for Droplet, we have a large order book. Like I said, we're at the DFM, DFA, setting up the contract manufacturing production line. So we're very, very close to shipping the actual commercial product. For Stream, we've done a number of different engineering and design verification prototypes. We're breaking ground on our first commercial pilot in Riverside, California, so about an hour east of Los Angeles, on what will be our commercial sort of product. So that's in partnership with some customers and the University of California, Riverside. We'll test that for about 6 months, give it the green light, and then we'll start the actual commercial deployments with those initial customers.
You're mentioning, of course, a lot of these customers are in places where water is in short supply. Do you envisage construction of multiple centers where you can manufacture to cut down on transportation costs, both financial and environmental?
Yeah, I think I mentioned earlier that we got a call from a customer saying, how do we skip the pilot and go directly to the commercial deployment in Colorado because of the situation there? And we're going through that process right now. It's a very busy time. That would require us to create, and for lack of a better term coming to my mind, an outpost in Denver to not only build it, but also to operate it and maintain it, as this is the first deployment. So we want to make sure everything goes right. There's going to be things that crop up, as you run it, and seasons change. Denver is a unique environment, so definitely, I think we will have to set up outposts in the early days if we're going to accelerate as quickly as things are presenting themselves.
Really interesting subject, and definitely something that is current and not going to go away. I mean, it's even hot and dry in Scotland right now. Stores are even selling things that we've never really seen in Scotland, called watering cans and sun cream. Who would have thought it? But it's great that AquaPoro is out there doing something practical. And equally as important, that they understand the environmental aspects of this too. I can definitely see more and more companies turning to this kind of technology, and it's also potentially a big help to biotech and pharma companies in arid climates, or even, as I mentioned earlier, maybe not so arid climates anymore. And so that's it for this week's podcast. If you do want to get in touch with guest opportunities, or if you want to advertise, please feel free to contact us at jim@deeptechdigest.com. So until next time, wherever in the world you are, I hope you have a great week ahead. Thanks for listening, and I hope you'll join us again next time for another Base to Base Biotech podcast. The Base to Base Biotech podcast is an Air Coastal Media Limited production.